Okay, sketching graphs of functions. So we've been sketching transformations of functions for 2 years now. So we should all be familiar with what the values in the following equation represent. So I don't know what this was referred to before. I call it kind of your sketching template or transformation template, where f can be any function, but the a, k, d, and c will be replaced by numbers. And you have to know how to interpret what those numbers indicate, what transformations have occurred. So let's go through them. So for a, when you look at the value of a, what transformations are indicated by that value? Vertical stretching compressions. Okay, so vertical stretch and compression. Now, I'm going to go into a little more detail here. So, it's a vertical stretch by a factor of absolute value A if absolute value A greater than 1. Does everyone understand why I've used absolute value symbol? Yeah. Exactly. A can totally be negative, right? A is allowed to be a negative value, but when you state stretches and compressions, you never want to include it, right? You never stretch by a factor of -2. Stretch by 2. Stretch by a factor of 2. So if A is bigger than 1, or the absolute value of A is bigger than 1, meaning 2, 3, 4, 5, or -2, -3, -4, -5. If you get an A value in that category, you know that you have a stretch. You have a vertical compression by a factor of, now this is where I differ from the book, and we had a brief conversation about this when you did that what do you remember page. So I'm just going to go for what I'm expecting. Okay, vertical compression by a factor of 1 over the absolute value of A if 0 is less than the absolute value of A is less than 1. So what this is saying is, if you get an A value that's a half, a third, a quarter, 3/4, a number between 0 and 1, when you state the compression, you're going to state the reciprocal of that when you state it. So this is the way, and I think it's logical. As soon as you said the word compression, you're already saying it's shrinking. It's going to be compressed, or it's going to be shrinking. How many times smaller is it going to be? 2 times smaller. So if A is a half, you're going to say vertical compression by a factor of 2, because that's what 1 over a half will be, right? 2. Making sense? Okay. The textbook answers will still say a half and a third, but you're just going to take the reciprocal in your head, because that's what I'm expecting. Fair enough? Okay. There's something else that A will tell you, other than the stretch compression part. Yep. Reflection in the, yeah. And if A is less than 0. I don't know if you need to write that, but okay. And it's reflection in the x-axis, not on the x-axis. Okay. You're not going to write a reflection on the x-axis. What is the x-axis? No, reflect in it. Okay. So reflection in the x-axis. Now for K, it's basically the same deal, except we're talking, instead of vertical, we're talking horizontal. So we got horizontal stretch and compression. And we're going to do the same thing here. So we have a horizontal stretch by a factor of, now this reverses. So this will be 1 over absolute value of K if 0 less than absolute value of K less than 1. And it's a vertical horizontal compression horizontal compression by a factor of K if K is greater than 1. So it's the opposite. So fractions inside, fractions near in the K location actually indicate stretches, and numbers bigger than 1 indicates compressions. So no matter what, when you state the factor of, the number you're stating should be bigger than 1. That's your kind of check to make sure that you did it correctly. Okay? And then, is everyone okay with, again, with the opposite values? It means it's the same reasoning behind why we did it with the A. And then what's the other transformation that can be indicated by K? Reflection in y-axis. Okay, so, by the way, guys, I'm fine with you using the V and the H short form for vertical horizontal on a test. So you can do that, it's fine. Okay? But you do need to indicate what type of stretch or compression. You can't just go stretch compression. You have to state either vertical or horizontal, either V or H. You can't leave it blank or else I don't know which one you're talking about. Okay, the other two are the easier ones. D. So D is going to be telling you what transformation? Horizontal translation or shift. You can use either word, I'm okay. It'll be D units right if D is greater than 0, left if D is less than 0. Okay, and C will be vertical. Same thing, but for vertical. Vertical translation or shift. D units up if C is greater than 0, down if C is less than 0. Do that if you want. So now that we've reviewed what the different, I'm going to call them parameters, A, K, D, and C. They're going to be replaced by values depending on what transformations are occurring. Now that we've reviewed what they mean, we're going to now just basically go through different examples that you can see in the homework. Yes, there will be some sketching, but there will also be some questions which are just stating, transformations or stating mapping rule, that sort of thing. So this is just a note on what I already talked about in terms of the stretch compression so that you can read that, just review that if you want to. Now, before we move on to the examples, let's review what the mapping rule is. I'm guessing that's the way you guys were taught how to do transformations. So what is the mapping rule? It basically is the way you take an equation and turn it into what you basically give instructions to what to do to the original point to get to your transformed point. So you have this general mapping rule where if x, y is on the parent, how do A, K, D, and C affect x and y to give the correct new point? So do we remember what values go with x? K and D, like craft dinner, okay? K and D go with x, okay? And how do they affect x? So the K, does anyone remember this? I mean, you have x. Yeah, x over K plus D. But then when you do the A, you don't have to put it over. It's AY. So there's your general form. So, and there's no taking reciprocals here or anything like that. This is literally you grab the number from the equation and you just plug it in here. Okay? So you use points on the parent, apply the mapping rule to determine the new location of the points, and then you graph the new function in the correct location, and that's how we graph transformations. Okay, let's do some. So example 1 says, state the transformations defined by the equation y equals 5 f at -2 bracket x plus 3 close bracket minus 4 in the order they would be applied to y equals f at x. So what I'm expecting here is just basically a point list, like bulleted list of the transformations in the correct order. Okay, so correct order would be from left to right. So don't start with translations are easy. I'll start with those. You can't start with the translations. These should be the order that transformations are applied, and you would never start by translating. Because then if you translate and stretch, then your points could get totally messed up of where they should be. Okay? So the first thing I see is a 5. What transformation is that affecting? It's A. So what the 5 is saying, I'm going to apply what transformation to F? Vertical stretch. Okay, so vertical stretch by a factor of, do I have to take the reciprocal of 5 or do I just write 5? Right, 5. Good. Vertical stretch by a factor of 5. Done. Next, I move along to the K value. And first thing I notice is the sign of that K value, and it is negative, so that indicates what transformation? Reflection in, yeah. And then now I deal with the actual value of K, the 2 part. What transformation has occurred? Horizontal compression by a factor of 2. Okay. So I'm done with A, I'm done with K, now I'm on to D. What's D telling me? Horizontal. You guys like shift or translation? Well, you pick. Horizontal translation, 3 units. Is it right or left? Left. And then last, vertical translation, 4 units. Down. Any thoughts where this question is going to fit on a quiz or test? Communication, right? Good job. Communication. It's literally 5 marks, right? Right there. Okay. Any questions? So far, so good? Okay. Example 2. The ordered pairs 1, 5, and -3, -6 belong to a function f. State the mapping rule from f at x to each transformed function and list the ordered pairs that belong to each of the following. So, we've got 3 functions. First thing, what you're going to do is state the mapping rule and then figure out the new points. So, it's not one of our parents, it's just these points are on a function and figure out where they go if they've been transformed. Okay? So start with the mapping rule. So a proper mapping rule starts with xy in bracket, a proper point xy with an arrow. And now you're going to write a second point applying a, k, d, and c. So what is the x coordinate of the mapping rule going to become based on the transformations in this question? It's going to be plus? X minus 2. You always got to be careful about x. You have to think opposite of what it looks like. And then for the y value, good. So because a and k were both 1 there, that kind of made it less painful. Okay. So now I'm going to write my new point, the original points. And we're going to just apply the mapping rule and see where is my new points going to be. Where are my new points going to be? So 1, 5. Where is that getting mapped to? -1, 2. Okay. And -3, -6. -5. Ta-da. Question answered. Okay, let's go for B. So what's affecting x for y equals -f at 3x? Is that affecting x? That's a so the k, anything that affects x is going to be in the bracket with x. So 3, that's a k value. So what do we have to do with that? Is it 3x or x over 3? Good. Okay. And so the y value is affected by the a value, and I get -y. So again, same to original points. I never, for a question like this on a test, I would never want to see a decimal number. So you would write fractions. Okay? So what would happen to 1 here? 1 over 3, and the 5 becomes, the -3 will become, and the -6 becomes, there you go. Okay, last one. Okay. Should I just start going to town with mapping rule here? The alarm is sounded. Because what do we have to do here? Factor, 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 make sure that the k is factored. Factor, 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 make sure that k is factored. So if you don't see a square bracket, that's like, you know, a big clue that, I think they might be trying to trick me here. Okay? Now sometimes there won't be, like in B there won't be, in A there won't be, because there was only K or there was only C, only D. But for this one, because whenever K and D are both involved and there's no double bracket, then you know that you have to do that factoring step. So what happens if you take out -3? You're left with x minus 3. So there's the proper form of the function before I state my mapping rule. So this one's going to be fun. Everything goes. There's a lot A, K, D, and C. So what's the x coordinate of the mapping rule going to be? So what are the operations you're going to have to perform to x to get the correct mapped point? X divided by -3, and then you're going to add 3 to it. For y, you're going to do a quarter y plus 2. If you write y over 4, it's correct, but you might just want to stick with ay plus c. Either way is fine. Okay, so we've got our 2 points we're going to transform. So this time there's going to be some operations with fractions involved. Okay, and while it's very useful that you should be able to handle fractions in your day-to-day lives, you know, at this point on a test like this, I'm looking for final answers. So I don't need to see a lot of your work here of how you would get your answer. So you can either do it on scrap paper or you can do it on your calculator. And I'm guessing by now we figured out the fraction capabilities of your calculator. Most of you figured it out? How your calculator can do fractions, or whether or not it can do fractions. So, if you don't have a calculator that does fractions, or you just want to do it for your own mental math excitement, you're putting in 1 in here, so you would have 1 over -3, or -1/3 plus 3, but you can't really add 3. You'd have to add the equivalent fraction, 9/3. Is everyone okay that we would have 8/3 as your x coordinate? For the y, you're putting in 5, so you're going to have 5/4 plus 2, but I can't really add 2, I have to add something over 4, so that would be 8/4, so I have 13/4. Yeah.
Do you care if we do mixed fractions?
Yeah, no mix, it's
No.
improper. Improper lowest terms is what I want, so I don't want 2 2/3. Now, some of your calculators will default to that, but usually if you go second fraction button, your calculator will go into improper.
Because what?
So if your calculator goes into mixed number form, if you go second fraction button, it will turn it improper.
Oh, okay. I will.
Okay? Some of you, or some of you might have a button, if you have a fancy calculator that says change. Press this change button and it changes it for you too. So all depends on how cool your calculator is. All right, let's do -3, -6. So -3 actually works out kind of nicely here. -3 divided by -3, 1 plus 3, 4. And then -6, not so fun. So I have -6 over 4, which is really -3 over 2 plus 2, which is really going to be 4 over 2, so I end up with half. We're good with that? So all of this is scrap paper or your calculator. Okay, you do that. I don't need to see it for full marks. I just need to see the correct points for full marks. Fractions only. Okay, no decimals. Okay. So you're going to notice I oriented this a little bit differently on the smartboard than on your paper. So you're working kind of down the page. I'm working kind of across just so I could do one per, have a little bit more room to write. So for each of the equations given here, we're going to state the parent function and the transformations that were applied, and then graph the transformed function and state domain and range. So first thing we have a few things to do. We have to state the parent, state the transformations, graph the function, state domain and range. So it's like a 4-step procedure here. And make sure you read the instructions on a test, because if it's at, I can't tell you how many people will forget the last part and they'll forget to do the domain and range. So be careful, underline it or something. So, or like right away, you're gonna say, okay, I have to remember to do this. So like write it down or something. So what is the parent? Parent function, so if you take away A, K, D, and C, what's left? Absolute value function. So y equals the absolute value of x. There's your parent. Now we're going to state transformations. So what's that half going to do to your function? Horizontal or vertical? It's inside with x, so that's the key, guys. It's inside with x, it's horizontal. Horizontal stretch. Horizontal stretch by a factor of 2. And vertical shift or translation, 3 units. Up or down? Down. Okay. So, stated the parent, stated transformations, graph, and state domain and range. So how am I going to graph this? Mapping rule. So let's get the mapping rule. So what's happening to x values? So the x coordinate of the mapping rule is going to be 2x. Is everyone okay why it's 2x? It's x over k, x divided by half, but what's the easier way of saying x divided by half? 2x, comma, y minus 3, there's your vertical shift. So there's your mapping rule. Now this is the part, this is why we reviewed all 7 parent functions the last 2 days. You need to know key points on all 7 parents. I would say a minimum of 3, a maximum of 5 is big. 3 to 5. You put 3 to 5 points here, figure out what the mapped points are, go to your graph, you should have a good idea of what the graph's going to look like.
Including 0 if it has 0?
Yeah, I would always pick 0. I'd always pick 0, 1, 2. Like I'd pick those, or whatever makes the most sense. 0, 1, 2, it could be, in this case, that's probably what I'd pick here. What I'd probably pick for this would be -1, 0, 1. Would everyone be okay with picking those as my x values? So if I pick -1, 0, 1, these are points on the parent. So what's the corresponding point on the parent when you put in those x values? 1, 0, 1. Okay? So let's figure out where those 3 points go. So -1, 1. So -1 becomes -2, and 1 becomes -2. 0, 0. It's always happy when this point's on a function. 0, comma, -3. 1, 1 becomes 2, -2. Okay. So we got -2, -2. 0, -3. 2, -2. Like my cool line tool. I know, it's pretty neat. So there's my function. That looked like the 2 transformations you stated. Does it look like that's what happened? Got horizontally stretched and moved 6 units, and moves 3 units down. Looks like it. It's always a good check to make sure it looks like it should. So what's the domain of this function? And let's maybe make a decision. Want to stick with our old school set notation, or do you guys want to jump into interval?
No.
Okay. So x can be any real number, right? You can take the absolute value of any real number. How about range? Y element real such that,
Size greater or equal to.
there you go. Ta-da. And if you're a rebel,
I really don't like that.
okay, shall we do the next one? Oh, question?
Just like when you're stating the domain and range and the interval one, should we put brackets around like the whole thing?
No.
No.
You can just do it like that.
And do you have to write like d equals?
Well, I should know what the domain and range is, so I would do d colon, not equals.
Sorry, yeah.
But you know, just to organize your solution, I would put d and r. Yeah. Okay, let's do the next one. Oh, there's lots more happening with this one. Extra exciting. Okay. So y equals -2 square root of -x plus 3 plus 2. So, everyone should have your radar on when you get questions like this. Is this good to go for stating everything? You have to check to make sure that K is in the right place, okay? So the K currently has not been factored out underneath that square root, so we have to do that. So we can maybe do it next to it and say y equals -2 square root. So what is K in this case? Negative, open bracket, x minus 3. So it changes the sign, which changes everything, right? It's important. Okay? Well, maybe not everything, but it changes the location, right? It's important to remember, or else you're going to lose a mark. So, parent, you might want to write, 3/4 of the size you wrote in the first one, because there's going to be more transformations this time, okay? So what is the parent in this function? You take away all the a's and k's, a, k, d, c, what are you left with? Square root function. Okay, stating transformations, the first thing you see is a what? A negative, which tells me reflection in x-axis. Then now I'm looking at the value, it's a 2. Vertical stretch. Vertical stretch by a factor of 2. Moving on to K. The K value is negative, so I have reflection in y-axis.
This is flipped fine, or do you want reflection?
Oh, reflection, come on, flip. No flipping. No flipping way, you're gonna say flipping, okay? And now that's on the video too, okay? So, the next, so is a K, or are we done with K? Is there anything else I have to worry about with K? No, because it's just -1, so 1 doesn't affect, we don't have any stretch or compression. So the next thing I'm looking at is the D value. What is that telling me? Horizontal translation. 3 units, right? And then vertical translation, 2 units up. So there's your stating of transformations. All right. So now we're into mapping rule time. Okay. So what's affecting x this time? Everyone okay with negative x? X over -1. Oh, I can just write that as negative x. And then I'm moving 3 right, so it's going to be +3. And then how about my y value? What's the mapping of the y going to be? -2y + 2. Good. Okay. Okay, now you have to, dig around in that brain of yours and figure out 3 points on the parent. Minimum of 3 points on the parent. 0, 0 is a good point to start with for square root. 4, 2, 1, 1. Now it's your call. You could do 9, 3 as well. More the merrier, or you can always go back and say, I think I want 1 more point just to get the enough of the shape to see it. That's your call, right? I need to see a minimum of 3. Okay? So, I'm plugging in 0, 0. It's our favorite thing to plug in. What's the result when you substitute in 0 for x and 0 for y? The point? 3, 2. 1, 1. So 1 is going to become 2, and the y value is going to become 0. And then 4, -4 plus 3, -1, and then 2, -2 times 2 plus 2, lots of 2's. Answer -2, I think. Okay? Not them. Join them. Bless you. Okay. So 3, 2, 2, 0, -1, -2. Remember where you started here, okay? It's a square root function. It has a starting point. It's 0, 0. Wherever 0, 0 moved to, that's where you start. So where did 0, 0 move to? 3, 2. And then I start there and I join from that point. And then just extend it a little bit more. Don't go crazy and extend it to the edge because you might you aim incorrectly. Does that make sense? You might be go off too much. So just extend it a little bit. Now, if you plot and just the way the translations go, your points are all smushed all together. That might be an indicator of I think I'm going to go for one more just to get a more of the shape to see. Because if all I see is like this, and all you do is that, like it's hard, you know what I mean? It's all smushed. Doing an extra point might just give you that little bit more of the correct shape. Okay? And so domain and range time. So let's go new school here. Interval notation, x. Where are my x values? What values of x are allowed here?
So, less than.
So, good. So that means it goes off to infinity negatively. So negative infinity, comma.
Less than 3.
Do I square bracket? And then the range. Do I start with the number or do I start with negative infinity for the range?
Start with the number. Negative infinity.
Yeah, negative infinity, and then the rising up, what's the maximum I'm going to hit? 2. Are we good? You're always reading a graph from left to right, yeah. Okay? If I see this, you're losing half a mark. Everyone okay with that?
If it was going the other way, the arrows might bend that one.
Yeah. Okay? So now, I think this is the last example. So the point 6, -7 is on the graph of y equals negative f at 2 times x minus 1 in brackets plus 3. Find the original point on y equals f at x. This one looks a little weird. I'm giving you the point that's already on the transformed function. Find the original. It's a little bit different. Makes you have to think a bit, right? Think about it. Thinking. Okay. So, shall we think about it for a little bit? What logically does that mean? If I know that point is on the resulting function, yeah.
You just have to switch the transformations that happen to it and do them in the reverse order and the opposite of them in order to get the points that originated from.
That's perfectly correct. Like you're going to do the exact. If you have mystery point and you did some transformations to it, you get the final. If you do the exact opposite operations in the exact opposite order, you should go back to the original. So it's kind of leading into the next topic, which is inverses, right? It's kind of going backwards. Now I'm going to show you a little trick that will do that for you, but it's easy to kind of figure out how to do it. And that is, I want you to state the mapping rule as is. So what would it be if I take a point, x, y, and figure out where it would go if I applied mystery point x, y on parent to this function? What do I have to do to original point to get to that function? So the first thing you're going to do is x over 2 plus 1, comma, negative y plus 3. Okay. Now I'm going to do something here, and I want you to kind of think about it. Mystery point xy needs to equal 6, negative 7. Right? That's the goal. Mystery point xy needs to map to 6, negative 7. And I wish there was something that equaled 6 in this scenario. Mm-hmm. Erica?
I think it's x over 2 plus 1 equals 6.
These are equal, guys. Whatever this is, you did something to x divided by 2 plus 1, you get 6. Is this making sense? And this is how you take original y and you get negative 7. You can set up a little equation and solve each equation. When you solve each equation, you're going to notice you're going to do the exact opposite in the reverse order, exactly what was said. Okay? So what I mean by that is you take your mapping rule and set it equal to 6. I have some mystery x. If I divide it by 2 and add 1, I need to get 6. Solve for x. That will give you the number. Make sense? And what are you going to do? You're going to, first of all, subtract 1, which is the opposite. Subtract 1, and then you're going to do what? Multiply by 2. Make sense? So for y, instead of adding 3, you're going to do subtracting 3, and then you're going to divide by negative 1, and you get. Now, you could go to map, you could say mapping rule from transform to parent and write the mapping rule, but you could do that if you want as well. That would work. Pretty good? Okay. So that is transformations. Let's start inverses. Okay. So the inverse of a function is found by switching the independent and dependent variables x and y in a given function. The domain of f at x becomes the range of the inverse, and the range of f at x becomes the domain of the inverse, which sometimes causes the inverse to not be a function. This can often be remedied by restricting the domain of the original function. So, do you guys remember a function that you would have to restrict the domain of in order for the inverse to be a function? Quadratic? Yeah, the quadratic would do it, right? If you have a quadratic, right? Don't have to draw this, but if you have a quadratic and you find the inverse, switch all the x's and y's, you would end up with sideways parabola, right, guys? And the problem is that red graph is not a function. But if you took away, you restricted the domain and you only made it half, okay, and this would go away and now you have a function. Is that ringing a bell? Okay. So that's what restricting the domain is all about. Okay? Quadratic was really the only one you did this for in grade 11, but maybe some other functions will fit that same characteristic this year. Now, the inverse of a function f at x is denoted by f inverse of x. This notation can only be used when the inverse is a function. So if you algebraically determine the inverse and the result is not a function, don't use that notation. Just leave it as y. Okay? Does that make sense? So just like y equals whatever. But if the result is a function, then you can use that f inverse of x with a little -1. Don't call it f to the -1 of x. That's wrong. F inverse of x. Okay? But you really should only use that notation when you're about to write a function. It's function notation. Does that make sense? Now, just like a key feature of inverses is that the graph of the inverse is a reflection about the line y equals x. You kind of saw it when I drew those parabolas. Okay? And then it is possible to find the inverse of a function algebraically by writing the function in terms of y, switching x and y, and then solving for y. So you switch the variables, that's basically the definition of an inverse, and then solve to get your result. Okay? So let's do a few examples. We're not going to get through all of them today. We'll get through the first couple, and then we'll continue and finish on Monday, because it shouldn't take 75 minutes for you all to get your lovely pictures taken. Okay. So, example 1, graph the inverse of m at x equals the absolute value of x on the grid. Determine whether or not the inverse relation is a function. So, graph the inverse. So maybe before, the easiest way to graph a function or graph an inverse of a function is if you know the original points on the original function, figure out a few of those, and then all you have to do is do what to those points? Switch x and y. So maybe we'll just do a little list here of points on m at x, points on the absolute value function. Why don't we pick 5 of them? We'll go -2, -1, 0, 1, 2. What would be the matching y values on the original absolute value? So take the absolute value of these five numbers, and what do you get? 2, 1, 0, 1, 2. Good. But we don't want to plot this one. We want to plot the inverse of this. So just make sure when you're plotting, you're going to plot the opposites. So what's the first point I'm going to plot? 2, -2. Then I'm going to plot 1, -1. And the next 3, it's really easy to interchange x and y, right? 0, 0, 1, 1, 2, 2. There's your absolute inverse of the absolute value function. Is that a function? What would you say? How would you justify it? This is not a function because good old vertical line test. So the inverse. So the inverse is not a function because the graph fails. Did you use VLT short form last year?
Yeah.
Okay. Okay, cool. So example 1 done. Okay, the formula A equals pi r squared is convenient for calculating the area of a circle when the radius is known. Find the inverse of the relation and describe what it can be used for. So A equals pi r squared, input radius, output area. We've used that formula for, I'd say you probably used it for the past 6 years in grades 6, 7, 8, right? So the inverse of this would be a formula where you input area, the output is the radius. Make sense? That's what the inverse would be. So how do I do that? Well, the one thing we're going to do is basically when it's a real life situation like this and you want to find the inverse of that relationship, don't switch the variables if the variables have meaning. Does that make sense? Like it's like a word problem, or it's a scenario where the variables actually have a meaning to them. X and Y are just kind of generic. We use them to graph anything, right? It's not like anytime when we just graphed the last question, there was not a context to the problem. But R means something, A means something. Don't switch them if they mean something, or else you're gonna get your mind blown because you're gonna be like, okay, now R now, because it's the inverse, now means area. What? Like, that's weird, right? So what you do is for real life problems, don't switch the variables, just isolate the other variable. Okay, so pi r squared, we want to isolate. So I'd say start by writing it in the reverse order and go pi r squared equals a, and now isolate your r. Remember doing that back in grade 9? Isolate. Here's a formula. Isolate the variable. So isolate r. So first step would be divide by pi. And then what do I need to do? Square root. Now, to be properly mathematically correct, anytime you introduce an operation like square rooting into an equation like this, what happens? Yes, correct. But now, can you justify why you don't have to worry about plus and minus?
Negative radius.
So since radius cannot be negative, r equals, so there's your inverse relation to a equals pi r squared. So the original function, you input radius, output area. Here you can input area, the output will be the radius. And now we're just going to test that, make sure we did that correctly. So use the equation given in part A to calculate the area of a circle with a radius of 5 centimeters. Express the area as an exact value in terms of pi, and then use the inverse relation to calculate the radius of the circle with the area you calculated. So basically this is going to be like, it's almost like a check, right? You're going to find the area when the radius is 5, and then hopefully when you plug that area into the inverse, you should get 5 out, right? So let's do it. A equals pi times 5 squared. So we want to keep this in terms of pi. So no calculator required, no typing in a pi button. What's that in terms of pi? 25 pi. And then now I'm going to use r equals the square root of, I'm putting in the area, 25 pi over pi. You see how everything's working out beautifully here? First thing you do is you divide the pi's out, and you're left with root 25, which is 5. Happiness. Okay? Okay. So basically the note here at the bottom, maybe I should have put it before the example, but I basically told you this. For equations that represent real life situations, do not switch the variables when you are determining the inverse. Okay? Now, so if g at x equals negative 5x plus 2, find A, g at 4, B, g inverse of 12, and then C, that thing. So if I get to that thing, you know, we'll get to that thing later. Let's worry about the first two. The first one, A, should be pretty straightforward. If g at x is negative 5x plus 2, g at 4 is just a plug and chug, which is terminology I tend to use. Okay, plug it in, chug your answer, right? Plug and chug. So you're plugging 4 in. So g at 4 is going to equal Negative 5 times 4 plus 2. What's that? Negative 18. Okay. Now, for B, G inverse of 12. Well, I don't have my inverse function, but I do have a little bit of space over here. Let's see if we can remember how this works. How do I find the inverse of a function? So you start by rewriting it y equals negative 5x plus 2, right? You don't want the function notation, you write y instead of your f at x. You're going to, I need to see this little statement, guys. Switch x and y, interchange x and y. You write that little statement to tell me what you're doing. So what do I have now? X equals negative 5y plus 2. And now you're going to isolate for y. X minus 2 equals negative 5y. Y equals x minus 2 over negative 5.
And Sept students, please excuse the following interruption as we have a few announcements for the end of the day. For any grade 9 still interested or haven't paid yet for Muskoka Woods, Monday is the last day to bring in forms and money. Also, for all grade 9s interested in joining student council as the grade 9 rep, please come to the math office on Monday after school to pick up application forms. If you are in grade 9 and you have not already submitted your sweater size, on Monday there will be a table outside the cafeteria to put those down and also to register your bus buddy. All students registered in Day e-learning, please come to the guidance office to pick up an instruction sheet today after school. Also, a final reminder that picture day is on Monday, so please be ready. Thank you and have a fantastic weekend.
So, are you guys okay? I kind of just got really math teacher-y right at the end there, because I'm not a fan of negatives and denominators, so that's what I did to just clean that up a little bit. Technically, mathematically, that, like, obviously either of those are equivalent. I am allowed to do this because this is a linear function. What's the inverse of linear going to be? The graph. So if you have a linear function, the inverse will be also linear. This is linear, and linear functions are functions. So the inverse of a linear will always be also be a function. Okay? So there it is. So now that I have an expression, now you can use this. Do you guys want to just stick with the original one with the x minus 2 over negative 5, or are you cool with this one? The second one? Okay. So if I use the second one, g inverse of 12, it's going to be negative 12 minus 2 all over 5. What's that going to be? Negative 2. Negative 10 over 5, negative 2. Perfect. Okay. Now, to answer part C, you don't have to do any extra work. Everything you need is on this page. Okay? G inverse of negative 18. Well, we never calculated G inverse of negative 18, but I did figure out that G at 4 equals negative 18. So what, right? So if G at 4 is negative 18, 4, negative 18, this is a point on G at x. This is a point on G at x. The point 12, negative 2 is a point on G inverse of x. If 4, negative 18 is on G at x, what point would be on G inverse of x? Negative 18, comma, 4. So there's where I can get it from. So G inverse of negative 18, I can replace that with a 4 minus negative 2 over negative 18 minus 12. So what do I have here? 6 over negative 30. What's that reduced to? Negative 1 over 5. Now this is kind of an interesting fact. I wanted to end today on an interesting fact. For linear functions, the slope of the inverse is the blank of the slope of the original linear function. Yeah. Isn't that neat? Because the original linear function there, the slope was mx plus b, right guys? Negative 5, and my slope here is negative 1/5 reciprocal. Not negative reciprocal, just reciprocal. Yes, sir?
Would you be able to answer number 6 and have A or B?
Well, b you had a. If you could have done what you just did here with g inverse of negative 18 because you found g inverse. You could put negative 18 in.
Yeah.
But it just, I saved you some work by purposely picking that point. Okay. So what's left, guys, is just more algebraic stuff. So it's going to be converting these functions into their inverses, and then that's it, pretty much. So we're almost done.
So is there homework?
So I'll tell you, your homework should be all of 1.4, and you can go ahead and do 1.5, it's 1.5, 1 to 7. That's what I assigned the other class. So you can, don't get to, the inverse questions will be more graphy slash, just inverting points and things. We'll save the algebra stuff for Monday, okay?